Hey guys, I want to talk to you about NATS JetStream's expected sequence headers. So, what are they? Well, it's a powerful feature for JetStream's optimistic concurrency control. So, what does it solve? This lets multiple processes work in parallel without locks. It'll detect and reject conflicting writes instead of just outright preventing them. So, it's pretty simple. These headers are for JetStream publishers, and these headers tell the server only accept this message if the sequence is what I expect. Streams maintain sequence numbers for each stored message. So imagine you have two writers that are racing to publish the next message. They both read that the stream is currently at sequence 4, so they both try to publish with expected last sequence 4. Only one succeeds, setting the sequence to 5, and the other is rejected because by the time it arrives, the stream is already at 5. So then it retries with expected last sequence 5 and succeeds. One thing to be clear on is that there's only one sequence counter, the stream sequence. Every message gets a unique incrementing stream sequence number. The expected sequence headers validate against this sequence. This is going to be important to remember because there's a few different headers and they all work slightly different. So essentially there's 3 ways to do this. Global, which validates on a per stream basis. It uses a NATS expected last sequence header. Per subject, which validates on a per subject basis, and it uses the NATS expected last subject sequence header. And per pattern, which, if you guessed, does it on a per pattern basis. And it uses the NATS expected last subject sequence header in combination with the NATS expected last subject sequence subject header. Don't worry, we're going to go over this. Again, remember, all 3 of these always validate against the same stream sequence, as in, the stream has one sequence counter. These headers just filter what they check against: the whole stream, a single subject, or a wildcard pattern. You'll see what I mean soon. So, some use cases for this are event sourcing. You can encode more information in subjects, and it's also used by atomic batch publishing. So let's check it out. So let's talk about global. Global sequence is the simplest approach. You have one stream, one counter, and every message increments it. If you're the only writer and need strict ordering across everything, this is what you want. All right, let's see how all this works. We'll start with global. This tracks the stream's last sequence number regardless of subject. So you could imagine it's a single writer with global ordering across all subjects. So this is what that looks like. For the first publish, the expected last sequence is 0, and we're publishing to events.order.1. Afterwards, the stream sequence will be 1. Next, expected last sequence 1, publishing to events.user.5, stream sequence ends up being 2. And then third, expected last sequence 2, back to events.order.1, and the stream sequence ends up being 3. And for each request, I'm using -h in the NATS expected last sequence header. So I created the stream. Let's run this real quick. And all 3 succeed because we're tracking the stream's global sequence. We went from 1 to 2 and then to 3. You could imagine it would fail if we skipped a number. All right, so let's make it fail. Let's check out the failure case. This time is simple. I'll have 2 separate writers. One will publish first to expected sequence 0, and then another writer will try to do the same thing. But it can't because now the sequence is 1. All right, fresh stream again. Writer A publishes with expected sequence 0 and gets stream sequence 1. Writer B also expected 0, but the stream is now at 1, so it fails. And you can see here it says wrong last sequence and gives us the last sequence number. So you could imagine using this when you need strict ordering across all subjects, like maybe a global event log. And here's a quick example of what one of these calls would look like in Go. You would use jetstream.withExpectLastSequence. Let's check out per subject. Per subject sequence lets you track ordering for each subject independently. Multiple writers can publish different subjects without blocking each other. The catch is that distinct subjects get their own tracking, so order.1.created and order.1.shipped are treated as completely separate. All right, so yeah, this one checks the stream sequence of the last message on a specific subject. Essentially, you have multiple entities publishing to different subjects, and you have optimistic concurrency per subject. So this is ultimately still using the stream sequence. but it checks what is the stream sequence of the last message on this particular subject. So for instance, we published to events.order.1 with the last sequence being 0. Now the stream sequence number is 1. And the last sequence for order.1 is now 1. Then you publish to events.order.2 with the last sequence being 0 because you've never published to this one before. The stream sequence ends up being 2 and the last sequence for order.2 is now 2. Publish again to events.order.1 and the last sequence was 1. Now the stream sequence is 3 and the last sequence for order.1 is now 3. And then again, events.order.2 publishes again with last sequence 2. Now the stream sequence is 4 and the last sequence for order.2 is 4. Again, remember the expected value is a stream sequence number, not an independent counter. We're going to show this off in a second. Also note, this time we're using the NATS expected last subject sequence header. So I reset our stream. I just want to quickly show that when all messages go to the same subject, the values just happen to be sequential, just like before when we were doing global. And you can see here we sent 3 messages to the same subject and we had the sequence numbers 1, 2, and 3. And they were all a success. Okay, so now we're actually going to run our initial scenario. Imagine you have 2 different writers to 2 different subjects. Events.order.1, first message. Expected sequence 0, and it'll set the stream sequence to 1. And now the last sequence for events.order.1 is 1. Order 2, first message, also expected 0 because there are no prior messages on the subject. Get stream sequence 2, last sequence for events.order.2 is 2. Order 1, second message, expected 1, get stream sequence 3. And last but not least, order 2, second message, expected 2, not 1, get stream sequence 4. So yeah, the common misconception is that each subject has its own counters starting at 0, 1, 2, 3, but the expected value is the stream sequence of that subject's last message. You track the return sequence and use it for the next publish. Let's quickly see a common mistake. We have 2 streams here. First, we're going to publish to events.order.1 created. We're going to expect last sequence to be 0, which is correct, and then we're going to set the stream sequence to 1. Then we're going to publish to events.order.1 shipped. We're going to say that we're expecting the last sequence to be 1, but it's going to fail because events.order.1 shipped is a different subject with no prior messages. Its last sequence is 0, not 1. So yeah, use this when you have multiple entities with independent life cycles. Each entity uses a single subject like events.order.id, and you need concurrency control per entity. The limitation, each distinct subject is tracked separately. You can't group related subjects like order.1.created and order.1.shipped. So for that, we use per pattern sequence. And this is what that would look like in Go. We're using the with expect last sequence per subject function. Per pattern sequence is the most flexible option. You define a pattern, and NATS tracks the last message matching that pattern. You're not just tracking against the subject you're publishing to, you get to decide for yourself. This lets you group related subjects together so order.1.created and order.1.shipped can share the same sequence tracking, while order2 anything stays independent. So per pattern checks the stream sequence of the last message matching the given pattern. And you can use this when you have multiple entities and multiple subjects per entity. So it works very similarly to per subject. In fact, this example is mostly identical, but essentially in this case, we're supplying the subject. We're supplying the pattern. It's not just checking against the subject that we published on. And for this, we're using the last subject sequence header and then the last subject sequence subject header. So really quick, I'm going to show if I group subjects for one entity, it works similar to how global worked. We're using the pattern events.order.1.fullWildcard. And so these 3 messages I'm going to publish will be events.order.1, but going to created, shipped, and delivered. And you can see this behaves pretty much just like global. Again, the expected value is a stream sequence number, not an independent counter. So all 3 messages succeed. Now let's do this with multiple entities. So let's start. We have order 1 created, which expects 0. The pattern is events.order.1 with a catch-all, and then stream sequence ends up being 1. Order 2 created also expected 0 because no messages match the pattern events.order.to catch-all yet. Stream sequence is now 2. Order 1 shipped now, expected 1, same pattern. Stream sequence is now 3. And now order 2 shipped, expected 2, same pattern. Stream sequence is now 4. And again, note that order 2's shipped message expects 2, which is the stream sequence of order 2's last message, not 1. And yeah, you can use this when entity events span multiple subjects, like order 1 created and order 1 shipped. Something like event sourcing, for example. So yeah, maybe confusing at first, but it's actually pretty simple. And this is what that would look like in Go. We're using the expect last sequence for subject function. And those are the last expected sequence headers. I hope this cleared some things up. So thanks so much for sticking around to the end. If this video helped you out or you just enjoyed it, a like really helps the channel grow. Subscribe if you want more and drop a comment below, whether it's video ideas, feedback, or just what you liked or didn't like. All right, take care, and I'll catch you in the next one.